Hi, my name is Shreyas Gupta, and this is a presentation about dark matter in our universe. So now, what do we know about dark matter? Well, scientists know that it's responsible for some sort of gravitational-like force in our galaxies. Vera Rubin was looking at the spin of these galaxies, and she saw the outermost stars were spinning way too fast to actually be held together by the gravity in the galaxies. And she determined that there wasn't enough mass within the galaxies to actually keep them together. So there must be some sort of unseen mass or unseen matter, which she determined to be dark matter. And using this, scientists actually figured out that about 80% of the universe is made of this sort of invisible dark matter. How do scientists know that dark matter is invisible? Well, because it doesn't interact with light in any ways. So, it doesn't absorb light, it doesn't emit light, it doesn't bend light. So we can't really see it. But we know that it's there because we can see the way it affects gravity, because it has mass. So we can see gravity and light bending more than it should if just the visible mass was there. And, it's very interesting to see that how by analyzing gravity, we found kind of an invisible matter. So now, what don't we know? We don't know what it actually is, right? We have some ideas about its properties or how it interacts with things in space, but we don't actually know what it's made out of, right? So that's kind of one of the key theories or not the key theories, but the key problems with dark matter is just trying to figure out what it actually is, right? And how is it actually working? Because we can see from its causes that it's working kind of like regular matter, and that it has some gravitational force aspects, but scientists don't know 100% what it's actually doing, which I think is really, really interesting. Now, how are we trying to learn more? We kind of already talked about this, but a lot of this has to do with, gravitational lensing or measuring things related to gravity. So gravitational lensing is just, measuring the bend of lights around galaxies, because galaxies have so much mass that they actually cause the light from other galaxies to bend and distort. And scientists can measure this bending and basically say, like, hey, if it bends this much, it should have about X amount of mass. And they can use this to kind of understand more about how much dark matter is present, and like kind of how dark matter is present and where it is in the universe. And then also, Stephen Hawking and also some researchers at MIT had a theory that, like a quintillionth of a second after the Big Bang, there were a bunch of tiny, tiny black holes made, right? And these primordial black holes, so to speak, are what's responsible for what we currently attribute to dark matter, right? Because these black holes would be so tiny that they're almost invisible to all of our detection methods that we have right now. So, but they still have immense amount of gravitational pull. So it's these tiny, tiny black holes could actually be causing what we attribute to dark matter, which I think is super, super awesome. It's a really cool theory. And, most of the science that's happening right now is trying to measure, what dark matter is doing. So you can look at the cosmic microwave background and be like, hey, there's some spots where it's a little bit altered because of dark matter and because of its gravitational shifting. And you can, again, use gravitational lensing and look at the light from these supernovas, like these candlestick supernovas, right, that we know the brightness of. So there's a bunch of different ways that scientists are trying to learn more about dark matter and the way it interacts with gravity. And hopefully they can use that to, try and figure out what this thing actually is. But the bottom line is that dark matter is a super cool scientific question and a scientific mystery that really is going to hopefully reveal a lot more about the universe that we live in. Thanks for watching.